Okay, so hello everyone. I hope my voice is clear to you and my screen is visible. Just let me know that my screen is visible to you or not.
Yes, madam. Yes, madam. Visible.
Okay, so thank you for that. And now we'll start the session in 2 to 3 minutes as I'm expecting some more students to join the class. Okay, then we will be starting the session. So just wait for 3 to 4 minutes. Okay.
Sure.
Okay, so hello everyone. So first of all, let me introduce myself. My name is Himanshi Singh. I am currently a PhD scholar at IIT Jodhpur, Department of Mathematics, and I'm currently pursuing PhD in broad area of probability and statistics. I'm a TA for the course Regression Analysis, which has been taught, which is currently running on NPTEL, and it is the classes are taken by Professor Soman Mehti. Okay, so here I'm taking the live session. So basically, for every week, the content is uploaded on the portal, and every week I just take the live session so that we can discuss the content which is being provided to you, and also we can have some practice session regarding the concept covered. Okay, so basically the live sessions are on every Monday from 6 to 8 p.m. So this is our fifth live session. So basically we are on fifth live session. Okay, and we have already covered four. We have already conducted 4 live sessions. Okay, so these are the important links. The first one is the Google Meet link by which you can join the class. Second one is the link to my YouTube channel where I'm uploading all the recordings of the live sessions. Third one is the Google Drive link where I'm uploading all the PowerPoint presentations, which basically I'm discussing in these live sessions. Okay, now plan for live sessions are basically I will be giving you a brief recap of the topics covered in the lectures, and then we will be doing some practice examples, and if you have any doubt then you may ask at the end of the session. Okay, I hope there is no doubt regarding these informations. So just let me know that if I'm changing the slide, then is it like visible to you whenever I'm changing the slides?
No, madam, it is in a first slide, regression analysis, live session 5. It's not changing.
Okay, okay, okay. I think it's now changing.
Yes, madam. Yes, madam.
Okay. Okay, so okay, okay. So just give me a minute. Fine. So basically, these are the slides. So these are the live session schedule, and this is our fifth live session, and these are the links, and this is the plan for the live session. Okay, so I hope there is no doubt regarding all this information. Then we'll just move towards the topics which have been covered. So I will be discussing first the topics which we have already like covered in the previous sessions. So basically in the beginning we started with the simple linear regression analysis, then we went for the multiple linear regression analysis, then finally we are studying that how to select best regression model. Okay, so the idea behind this is that we in the model we can have a large number of regression regressors, and some regressors may be irrelevant. So basically we want to remove the irrelevant regressors. So this whole process in order to select the variable. Okay, if you want, so for example, if I have a model y is equals to beta naught plus beta 1 x1 till beta k minus 1 x k minus 1. Okay, now I want to find a subset of the regressors which can explain the variability in the y in a best possible way, and I just want to reduce the number of regressors in order to reduce the computation. Basically, I do not want irrelevant regressors to be in the model. So for that I need a process basically. So the process in order to select that subset of regressors is called the variable selection process. And for this process there are two methods. Okay, so we discuss two methods. So first method is the all possible regression, so where we basically consider all possible regressions and we calculate r square, we calculate adjusted r square, we calculate ms residual, we calculate the Welch statistics, and based upon certain assumptions, based upon certain methodologies, we decide that which is better compared to the other. So this or for all possible regression, in the previous live sessions we have discussed about this concept, that is this process, that is all possible regression where we are considering. However, for today, we will be discussing on the sequential selection process. Okay, so here we have three processes in it. Okay, we have backward elimination, we have forward selection, we have stepwise selection. Okay, so we have basically three processes, uh, where we are basically, the main idea is that we consider, for the backward elimination, we consider the whole model. Okay, and one by one we start rejecting the variable which is irrelevant. Now, what is the rejection rule? How do we do that? I will be discussing it further. In the forward selection, what we do, we consider the model where, when there is no variable, no regressor, then we start with one regressor, two regressor, three regressor, and like we stop where a certain threshold is reached. Okay, and in stepwise selection, it is kind of a combination of backward elimination and forward selection. So it is kind of a broad idea about the processes. We will be discussing them in detail. Okay, before that, let me start with partial F test. So this we have already discussed. So I'm just reminding you the statistics, the partial F statistics, because we will be using this statistics in order to like decide whether the regressor, a particular regressor is relevant or not relevant. Okay, so for that we know, so for example, if we consider this hypothesis H naught, where, so for example, we have y is equals to this multiple regression, linear regression model, y is equals to beta naught plus beta 1 x1 till beta k minus 1 x k minus 1. So this model we have. Okay, we want to check that whether the xith regressor is relevant or not relevant. So for that, we just test the hypothesis beta is equals to 0. Okay, against the hypothesis, the alternative hypothesis that beta I is not equals to 0. Okay, now for this we have F statistic, partial F statistics, that is equals to F is equals to SS regression for the full model, okay, minus SS regression for the model except xi, okay, divided by ms residual for the full model. Okay, and this basically follows F distribution with 1 comma n minus k degrees of freedom. Okay, so we reject H naught if this F is greater than F alpha 1 comma n minus k. So this we have studied already. Okay, so this is basically the partial F test by which we basically test this hypothesis. Now, in place of this, if in place of this alternative hypothesis beta not equals to 0, if this hypothesis were for any subset, in place of only beta I, if there was a subset, like for example beta 1, beta 2, beta 3 equals to 0, versus it is they are not equals to 0. So for that hypothesis, this formula will be like, in general, SS regression full minus SS regression for the model except x1, x2, x3. Okay, or we can say that regression for the restricted model, okay, divided by the ms residual for the full model. And this will be, so this will be one, so this will be 1, and this will be chosen accordingly, whatever the full model is. So the n minus k will be the total n and the number of regressors, number of parameters which are present there in the model. Okay, so this will be so here we have considered only for one beta I. If there is more than one beta I also, here we can replace it it with model except, for example, in place of beta I we have beta 1, beta 2, beta 3. So we will be here writing model except x1, x2, x3. Okay, and find the SS regression, and we'll find the difference, and we will be finding out the F statistics and do these things. Okay, so this is the partial F test. So how we will be using this partial F test in order to do our variable selection process. So first of all, we'll discuss the backward elimination. So for example, so for backward elimination, first of all, we'll start with full model. Okay, we'll start with full model. So that is, for example, y is equals to beta naught plus beta 1 x1 So let us consider that we have only 4 regressors. Okay, so we are considering here this is the full model. We have only 4 regressors with us. This is our full model. So we'll start with it and we will try to eliminate any one of them. So for that, what we will be doing, we'll find the F statistics. We find F statistic. Okay, or we'll find the F statistic for each regressor in presence of other regressors. Okay, so what we'll do, basically we'll find F statistic, okay, for x1 in the presence of x2, x3, x4. Okay, we'll find F x2 in presence of F x1, x3, x4. We'll find F x3 in presence of x1, x2, x4. Again, we'll find f x4 in presence of x1, x2, x3. We'll find these values, okay, and we'll see for whichever the value of f statistic is least. Okay, so we'll select the least value from it. So let me take a blank page. Okay, so here we'll select f least from all these 4. Okay, then we will compare it with f alpha 1 comma n minus k. Why n minus k? Because we have the full model with us. So because this is the full model, the k is the so the n is the total number of observations we have, and k is the number of variables we have, number of this sorry parameters we have, beta naught, beta 1, beta 2, beta 3, beta 4. So we have 1, 2, 3, 4, 5 parameters. So our k value is 5 here, and because I'm considering just a illustration here, we do not have the value of n. If we have the value of n, then we'll find it this. And now if f least here, this f least is less than f alpha 1 comma n minus k, then we eliminate the corresponding regressor. Okay, so basically if for example, if this was f least among them, if this was f least, then we'll eliminate the regressor x1. Okay, further, if x1 is for example, if it is eliminated, then we are left with x2, x3, x4. So now our model will be y is equals to beta naught, x1 is eliminated, beta 2 x2 plus beta 3 x3 plus beta 4 x4. We'll again repeat the process. Okay, we'll again repeat the process and we'll do this thing until this condition uh, like does not hold. So we will land up to a condition when we are finding out the f statistics and the value of f statistics is greater than this tabulated value of f for all possible scenarios. Okay, so basically I will be doing an example on it, then it will be more clear. Okay, so first of all, I'll do an example on it, then we'll discuss other methods. Okay, so just So we'll do an example on it first. So here consider this multiple linear regression model. Okay, then we have a data here. Okay, so here this data basically is that these are the regressors which are in model. So here this means that x1 is in the model. Okay, here this means that x2 is in the model. Here this means that x3 is in the model. This means that x1 x2 are in the model. Okay, this means that x1 x3 x2 x3 are in the model. Okay, and this means that all four are in model. So in short I have written, okay, and these are the corresponding residuals. So one thing I want to mention here, so here basically we are considering this multiple regression model, where we have total four regressors and we have these values. So if we have this kind of models, then we have this SS residual with us. Okay, so we have this SS residual with us. But just see here, then whenever we have defined this F statistics, then you can see that here SS regression is given. Okay, here SS regression is given. So in place of SS regression, we only have the information about SS residual. Here SS residual is given. Okay, so we have two ways to do it. Either, since we have in the previous class we have discussed that with no regressor the SS residual is equals to the SS total. So this will be SS total only, because we have the SS residual with no regressor, that is equals to the SS total only. In last class we have discussed this. So by using this SS total and using this SS residual, we can find out the SS regression easily. Okay, otherwise, so this is the one method in order to find out the SS regression, to find out the F statistic. Okay, other than this we can also have different methods. So for example, I want to calculate, so the F statistic. So first of all, the F statistic is given by the F statistic is given by F is equals to SS residual for the full model minus SS residual for the restricted model divided by MS residual for the full model. Okay, we do not have regression here. Now we do not have this regression, we have residual. So I'll change the formula in the form of residual. Okay, so how to do it? We know that SS total is equals to SS residual plus SS regression. Okay, so if I'm considering this for full model. Okay, now if for restricted model also, we know that SS total is equals to SS residual for the restricted model plus SS regression for SS regression for the restricted model. So this condition holds, so both the equation are true. If we solve both the equation, subtract 1 minus 2, if we do that, so left hand side will become 0. So this is equals to this minus this, so that is SS residual for the full model minus SS residual for the restricted model plus SS regression for the full model minus SS regression for the restricted model. Okay, and here if I take this residual term in the left hand side, so we get SS regression for the full model minus SS residual SS regression for the restricted model. So here you can see SS, I'm taking this in the left hand side and this in the left hand side. So that is SS, no, I'm taking the residual term left hand side and I'm keeping this in the right hand side only. So SS regression for the full minus SS regression on the restricted is equals to SS residual on the restricted minus SS regression for the, sorry, SS residual on the full model. Okay, so we can write f statistic as f is equals to, in place of this quantity I can write this quantity. So I can write SS residual on the restricted minus SS residual on the full divided by MS residual on the full. Okay, so either I evaluate this quantity or I evaluate this quantity, both are same. Okay, so since I have only SS residual with us, okay, to make my life easy, I will be using this formula. Okay, so we will be using this formula. Fine. So now let us go towards the question. So for forward selection, in the question it is given, starting from the null model, which variable will be selected for? So, okay, sorry. So it is for the forward model, but we have only discussed about the backward elimination. So we'll first discuss the question on backward elimination. Okay. So starting with the full model, which variable will be eliminated first?
Madam, I have one small doubt.
Yes.
You are written that SST equal to full model for SS regression minus uh, yes. Here both left hand side SST is same
Yeah,
because
SS total will always be same. SS total will not be changing.
my question is second equation for restricted also we get same SS total.
Yeah, SS total will be same only. So if you change basically here what we are saying, that if we are considering a restricted model, for that
Yes.
if we are considering the restricted model, SS total will be same only.
So, okay. Okay. Thank you.
Okay. So okay, so we'll move forward. We will be using this. Okay, and we'll now discuss the question on backward elimination. Okay, so for the backward elimination, first of all, we'll start with the full model. So y is equals to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4. Okay, so we'll, in order to eliminate, we'll first test, we will find out the f statistics. Okay, for the model uh, where we are taking the restricted model, that is where x4 is not present, and the full model to be this model. So basically we want to test for the x4 in presence of 1, 2 and 3. Okay, and then we want x3 in presence of 1, 2, 4. Then we want f 2 in presence of 1, 3, 4, and f1 in presence of 2, 3, 4. Okay, so we want these values. For this, basically we want, if I want to find out here, let me write it in a more cleaner way. So that implies that we want SS residual for the restricted minus SS residual for the full model divided by MS residual for the full. Okay, now our restricted model is what? Restricted model is which consists of 1, 2 and 3, because we want to test that whether this with 4 whether the model is good or not. Okay, So our restricted model is when there is a, so here restricted model is f is equal, so y is equals to f x1 x2 x3. Okay, so this is our restricted model because we are testing on x4. So for that, f4 in the presence of 1 2 3 will be ss residual when 1 2 3 are present minus ss residual when all are present 1 2 3 4 divided by ms residual when all are present. Okay, now here if in place of residual we had regression, ss regression, then that would be ss regression for the full minus ss regression for the restricted. Okay, so that is the difference. Okay, further let us calculate it. So since this is the first one, so I'll just elaborate a little, otherwise we will do it directly. So f4 1 2 3. So this is SS residual for 1 2 3. Now if I see the data, SS residual for 1 2 3 is giving 105. Okay, so it is 105 minus SS residual for the full. So that is 100. Okay, so this is 100 divided by MS residual. So that's the MS residual for the full is SS residual for the full divided by n minus k here. Okay, so n is, so assume let n to be equals to 25. Okay, and also alpha is equals to 0.05. So these are the two assumptions we should take in the question. So n is 25 and k is, how many k we have here, how many parameters we have? We have 1 2 3 4 5 parameters. So k is 5. Okay, so here it is 105 minus 100 divided by SS residual for the full was here only, so it is 100 only, divided by 25 minus 5, that is 20. Okay, so this is 105 minus 5, it is 5. Okay, and this is 5 again, so it will be 1. So we found the value of f4 1 2 3 and it came out to be 1. Similarly, if we find the value of f2 1 3 4, okay, so that what it will be? So f2 1 3 4. So that will be the SS residual for the model 1 3 4 minus SS residual for the 1 2 3 4 full model divided by ms residual for 1 2 3 4. So if you see here, this one, this quantity and this quantity is same, only this quantity is changing for this particular elimination. So only this is changing. So we'll only change this. This will be 100 and divided by 100 by 20. So this is minus 100 divided by 100 by 20. So that is 5. Only SS residual 134 is changing. So SS residual 134 is 125. So it is 125. Okay, so it will be 25 by 5 and it is 5. Now again, f, so we have calculated two things. We have calculated f4 1 2 3. We have calculated f2 1 2 1 3 4. So that came out to be 5. Now we'll calculate f3 1 2 4. f3 1 2 4. Okay, so here it will be SS residual for 1 2 4 minus this quantity will be same, so that is 100 divided by 5. So SS residual for 1 2 4 is 120. So it is 120 minus 100 divided by 5. So it is 20 by 5. So this is 4. Similarly, just calculate f. You just calculate the last term. So this came out to be 4. F1 in the presence of 2, 3, 4. Just calculate this. Here is the table. Here is the table. You need this value. So what will be, so let me write. Just calculate this value. I have written here the value of SS residue.
160 minus 100 divided by 5.
Yeah,
60
so it
divided
is okay. So it is 60 by 5, 12. So we'll see that which one is least. So it is 12, it is 4, it is 1, it is 5. So this one is least.
one is least.
Yeah, so it is least. Okay. So here we can say that F4 given 1, 2, 3 is least. Okay, which was 1. Okay, now calculate the tabulated value f alpha 1 comma n minus k. N minus k was 20. Okay, so f 0.05 comma 1 comma 20. So that we will calculate using the f table. So here it is the f table. 1 and 20 in the denominator. So this value 4.35. Okay, so this is our f tabulated 4.35. Okay, so here f4 in the presence of 1, 2, 3 that is equals to 1 is less than 4.35. So what this implies? This implies that we eliminate x4. Okay, so since this is less than 4 point, if it was not less than, so it is least. If it is not less than 4.35, then we will not eliminate x4 and we will not do any further analysis. We'll say the whole model, every regressor is significant. Okay, but since this is less than 4.35, so we'll eliminate x4 now. Now further, now our full model will not be having x4. Okay, so we'll now have the model. Now our full model becomes y is equals to function of x1, x2, x3 because we have eliminated x4. Okay, now we'll do the same analysis on this. How to do that? So what we'll calculate? We'll calculate f. Okay, 1 in the presence of
2,
3,
3.
f
F
in presence of 1,
1,
3, f3 in presence of 1, 2. Okay, so this will be SS residual for the restricted model. So that consists of 2, 3 minus SS residual for the full, that is 1, 2, 3 divided by SS residual for 1, 2 and 3. Okay, so SS residual 1, 2, 3. First of all, I'll write that.
SS denominator SS residue 1 to 3 by degree of freedom.
Yeah, MS residual. Okay, here it will be MS residual. So SS residual 1, 2, 3 is 105. Okay, so it is here 105. Okay, and here it will be 105 divided by n minus k. So here n is 25. Now what our k is? Since we have 3 regressor variable, now our k becomes 4. Okay, because now our full model consists of 3 regressor variable and 4 parameters. So k value will be 4. So now degrees of freedom for this will be n minus k, so that is 21. Okay, and SS residual 2, 3. So it is 190. So now this is equals to how much? So just calculate this value.
Final answer is 17, 1 7.
Okay, here it is 17. Okay, so what will be the next? F2 in presence of 1, 3. Here I need to write S13. So S13 is SS residual 155.
Answer is 10.
Okay, just wait a minute. Let me check. So we are doing the backward elimination. So calculate the next one if it is done. So here we are doing the backward elimination. So yeah, answer is 10 for it. Okay, and SS12 is 140. So SS12 is 140.
7.
Okay, so this is 7. So this is 17, this is 10, this is 7, and this is the least. Okay, now we'll calculate F alpha 1 comma n minus k degrees of freedom. So n minus k is 21 here. So 21 here. So this is F 0.05 1 comma 21. So let us find out that value. Numerator degree is 1, denominator degrees is 21, so it is 4.32. So it is 4.32. And here you can see that this is greater than 4.32. So this is greater than 4.32. So each of the values greater than 4.32. So we cannot eliminate. Now since F312 is least but greater than 4.32, this implies we cannot eliminate further. Okay, now we cannot eliminate any of the regressor. So okay, so final model is y is equals to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. Okay, so here in the question what it was asked, okay, that starting with a full model, which variable will be eliminated first? So we have eliminated x4 first. Okay, so this was eliminated at first only. Now what is the next question on this? After first elimination, which variable will be eliminated second? So after first elimination, we have eliminated something or not?
Nil.
No. So no elimination. Okay, no elimination at seconds. Okay, further in the next, after two variables have been eliminated, which will be eliminated next? Again here no elimination, because we have already reached the elimination and we have already reached the threshold. We cannot eliminate further. In the next question, what will be the final model obtained by backward elimination? So the final model will be y is equals to beta naught plus
Plus
beta
beta 1
1.
x plus beta 2 x2 plus beta 3 x3.
Yeah, so this is your final model. So this is the process for the backward elimination and the illustration we have given. Now we'll talk about the forward selection. Okay. So for the forward selection, we are basically start with. So we start with no regressor. Okay. Then uh, then what we'll do, we'll just include one of the regressor, and then we calculate the f statistic value. Okay. So just a minute. So what we'll do, so we'll find, so basically what will happen, so let me write it in another way. Then so we are, since we are considering, so for example we consider y is equals to beta naught plus beta 1 x1 till beta 4 x4. Okay, so then so total are 4 regressor, but we'll start with, so we start with
Y is equal to beta
beta
naught plus beta.
we'll start with this. Okay, then what we'll do, we'll include another model, so sorry, another regressor, then we include each regressor. Okay, so we will have four models. Y is equals to beta naught plus x1 beta 1, y is equals to beta naught plus beta 2 x2. Okay, y is equals to beta naught plus beta 3 x3, y is equals to beta naught plus beta 4 x4. Okay, so we included at for every model we included like one regressor. Okay, so one regressor when we added, for each of the model we'll calculate the f statistic. Okay, we'll calculate the f statistics, then further we find f maximum, so whatever the maximum from it. Okay, so now if f maximum is greater than f tabulated. Okay, so if that f maximum is greater than f tabulated, okay, then we include the corresponding regressor. Okay, so if it is greater than that f tabulated, then we'll include that regressor. Okay, then further we'll consider so for example we include x2 at first step. So now our model becomes y is equals to beta naught plus beta 2 x2. Further what we'll do, further we'll again add another variable, another regressor to it. Okay, then we'll calculate f, for example x1 in the presence of x2. Okay, f x3 in the presence of x2, calculate f x4 in the presence of x2. We'll calculate these three statistics, then again we'll see that what is f maximum. Okay, again we'll see f maximum. Now if that f maximum is greater than f tabulated, then we'll include that particular corresponding regressor. Okay, and if not, if there is no value which is like greater than f tabulated, every value is less than f tabulated, then we'll just stop the process. Okay, then we will do no more like addition. Okay, so is it clear?
Yes, madam.
Okay, so we'll do a question on it. Okay, so here this question was there, that starting from null model, which variable will be selected first? So same data, same thing we have. Now on the same data, we want to do forward selection. Now in the first question, it is asked that starting from the null model, which variable will be selected first? Okay, so we have null model, and null model is y is equals to beta naught, and we will just want to find out the f statistic. Okay, one like x1 in the presence of nothing, f statistic 2 in the presence of nothing, f statistics for 3 in the presence of nothing, and f statistic 4 in the presence of nothing. Okay, so for that I have to find ss residual restricted. Okay, so restricted here, the restricted model is y is equals to beta naught. Okay, so that is for y is equals to beta naught. The restricted model is this, minus ss residual and y is equals to beta naught plus beta 1 x1, this model, divided by ss residual for y is equals to beta naught plus beta 1 x1. Okay, so this will be the values we need to calculate.
MS residual.
What?
Denominator MS
Yeah,
residual.
okay, means residual, sorry. Okay, so for this, um, what are the values? Yeah, so for this we will have so on the table we have SS residual for the y is equals to beta naught, means no regressor. So this is the SS residual only, so that is 300. Okay, so it is 300 minus SS residual for when x1 is in the model, so that is 180, divided by 180 divided by what will be n minus k here, n is 25 already. Now since our full model is this, so k will be what?
2.
2, yes. So it will be 25 minus 2, so it is 23. So what is this value?
15.333.
It is 15.33. Yeah. And for this one, we'll change here that beta naught plus beta 2 x2. So SS residual for y, this model will be this same only, minus SS residual when x2 is in the model. So that is this one, 240, divided by 240 divided by 23. What is this?
5.75.
Yes, it is 5.75. Okay, so in now 3 in the presence of nothing, so this is 300 minus when 3 is in the model, so this is 210, divided by 210 divided by 23.
9.857.
9.8.
857.
And this f4 in the presence of nothing, so in the model when x4 is there, so this is the value 270, divided by 270 divided by 23.
2.5556.
2.55.
56.
Okay, so we'll see what is the maximum value here. So maximum value here is this one. Okay, so f1 in the presence of nothing, so that is equals to 15.33 is maximum. Okay, and we'll see that whether it is greater than our f tabulated or not. So what is our f tabulated? So f alpha 1 comma n minus k, and n minus k is 23 here, so it is 23. So f 0.05 1 comma 23, so let us see in the table.
5.75.
No, it is 4.28.
Oh, sorry, ma'am.
Yeah, so it is 4.28 from the table. So 4.28. So f1 in the presence of nothing is greater than f alpha 123. Okay, so this implies that we include x1 in the model. Okay, now what our model becomes? So now our model is y is equals to function of x1. Now we have this. Now further what we'll do, further we'll try to include other variables in the presence of x1. So what we'll find? So we find f statistic, okay, for x2 in the presence of x1, f statistics for x3 in the presence of x1, f statistics for x4 in the presence of x1. Okay, so for this, we have SS residual for the restricted one. The restricted one is when there is only x1 in the model, minus SS residual for the full model, and the full model is x1. So this is our model, but when we are doing this x2 in the presence of x1, so our full model consists of x1 and x2 both. Okay, divided by ms residual for the.
X1, X2.
Okay. So SS residual for the x1 is 180, and x1 x2 is 140. So it is 180 minus 140 divided by 140 divided by what is the degrees of freedom here, k. Now k is uh, since we have full model as 2 regressors, so k will be 3. Okay, so n minus k will be 25 minus 3, so it will be 22. Okay, so what is this value?
6.2857.
6.2857. Okay, and similarly we'll do this SS residual for x1. So this is a restricted model, minus SS residual for x1 comma x3 divided by ms residual for x1 comma x3. Okay, so this is equals to SS residual is 180 only, minus this is for x3 we are doing. So x1 x3 it is 155 divided by 155 by 22. So what is this value?
3.5484.
Okay, so I'll write it on the next page. um, f of x2 x3 in the presence of x1. So that came out to be what? What was your answer? 3.55.
Yes, madam.
Okay. And then we'll find out x4 in the presence of x1. So that will be SS residual for x1. So this is a restricted model. SS residual when x1 and x4 both are in the model divided by MS residual for the x1 comma x4. Okay, so SS residual for the x1 we have already 180 with us, minus SS residual for 1 when 1 and 4 are in the model, so that is 165. So it is 165 divided by MS residual, so that is 165 divided by n minus k, so n minus k is 22 with us. So here it is 22. Just calculate this.
2.
Okay, so this is 2. Now we'll see what is maximum. So here it is 2, this is 3.55, and this is 6.28. So this is maximum. So just give me a minute. Okay, so this is the maximum, this one, fx2 in the presence of x1. So here fx2 in the presence of x1 is equals to 6.28, 6.2857. So this is maximum. Okay, now what f tabulated is f alpha 1 comma 22. Okay, so we'll find out that tabulated value f alpha 1 comma 22.
4.30.
Yeah, it is 4.30. So it is 4.30. So this is greater than 4.30. So if this is greater than 4.30, so basically we'll include x2 in the model. Okay, so we include x2 in the model. So now our model y is equals to f of x1 was included first, x2 is included second. Okay. Fine. Now we'll test for x3 and x4 both. Okay, so whether we'll include x3 or not, whether we include x4 or not, let us see. So we want f x3 in the presence of x1 x2, f x4 in the presence of x1 x2, whether we want 3 in this step or we want 4 in this step. So for this, we have SS residual for the restricted one. So that is, it consists of x1, x2 minus SS residual for the full model, and full model here is x1, x2, x3 divided by MS residual x1, x2, x3. Okay, so this value is when x1, x2 is there in the model, so it is 140, and when all three are there, it is 105. So it is 140 divided by 105. So 140, sorry, minus 105 divided by 105 divided by n minus k. Now the total regressors we have 3, so k is 4. So n minus k is 25 minus 4. So this is, so previously we had the degrees of freedom 22. Yeah, so it is 21. So So what is this value?
7.
So it is coming out to be 7. Yes. And if we do this for x4 in the presence of x1 x2, so it is ss residual x1 x2, so that is 140 only, minus ss residual when x1 x2 x4 are in the model. So x1 x2 x4, so this is 120. This is 120 divided by 150, sorry, 120 by 21. So what is this?
3.5.
Yes, it is 3.5. So which one is bigger? This one is bigger. Okay. So F3 in the presence of 1, 2, this is 7, which is the maximum value. Okay. Now what is F tabulated? So F alpha 1 comma, what is the degrees of freedom? 21. So 21. So what is this value from the table?
4.32.
Yes, 4.32. 4.32. And this maximum value is greater than 4.32. So F3 given 1, 2, that is equals to 7 is greater than F alpha 1 comma 21. So this implies we include X3 into the model. Now we'll test for X4. So we have included 1, 2 and 3 here. We test for X4. Now our model is y is equals to F x1, x2, x3. So we want to find the statistic F4 in the presence of 1, 2, 3. Okay, and that is SS residual, the restricted one, that is 1, 2, 3 minus SS residual for the full model 1, 2, 3, 4. Okay, divided by MS residual 1, 2, 3, 4. Okay, let us find out this. So SS residual 1, 2, 3 is 105, and for all 4 it is 100. So it is 105 minus 100 divided by 100 divided by n minus k. Here n is 25 and k is, since we have 4 regressors, so k is 5 here. So 25 minus 5, it is 20. Okay, so this is 5 upon 5, so this is 1. Okay, now calculate the F tabulated value, F alpha 1 comma 20. What is this value?
4.35.
Yeah, we had calculated that before also. Sorry, we have seen that before also. So it is 4.35. So here it is 4.35. And you can see that F4 given 1, 2, 3, that is equals to 1, which is less than F alpha. So we will not include because it is less than the tabulated value. Okay, so we will not include the. So since F4 given 1, 2, 3 is equals to 1, which is less than F tabulated. So this implies X4 cannot be included and the algorithm is terminated. Okay, so our final model will be y is equals to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus epsilon. Okay, because we cannot add x4 further. Now in the next questions, similar kind of questions are asked. Basically, after selecting the first variable, which variable will be selected second? So first we have selected x1, then at second step what we have selected?
I think X2.
Yeah, so we have selected x2 at second step. Fine. And after x2, after two variables have been selected, which variable will be selected third? So at
X,
third, we selected,
x3.
yeah, so we selected x3 after x1 and x2. Fine. And in the last question, it is asked what is the final model obtained by the forward selection. So final model was y is equals to,
Beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus epsilon.
yes. So it was our final model. So this is about the forward selection method. Now one more method is left with us, that is the stepwise selection. So we'll discuss that. Okay, there are minor differences with the forward selection. So basically we are merging forward selection and backward elimination in this stepwise selection method. So basically what we are doing, we'll start with the no regressor model with no regressor. Okay, so just give me a minute. Yeah, so first of all we'll start with, so we start with no regressors. Okay, then again as we are proceeding in forward selection, we will be proceeding in the same way. Okay, we'll then what we'll do similarly as of the forward selection. Okay, we will find out all possible model with one regressor. Okay, compute f statistic. Okay, okay, then find regressor having highest f statistic. Okay, now having highest f statistic, we'll select the model directly, will not compare it with the f tabulated value. Okay, so we'll find the regressor having highest f statistic value and select it or add it to the model. Okay, so basically we'll not compare here with the f tabulated value. Okay, so also here we'll not compare the values of the f statistics with the f tabulated. We'll compare it with some threshold value. Okay, now that threshold value will be provided to you by the, like in the question, or by the uh, in the question itself it will be given that for what value we have to compare it with the f statistics. We have to compare it with the whatever value they will be giving you. You do not have to compare it with the f tablet value for this stepwise selection. Okay, so
Madam, F threshold values, every problem it is different. Is correct, madam?
yeah, for every problem it is different. Maybe
Okay.
so we so here in the question I have not given anything, so we'll consider for this question, for the next question which we will be discussing, we'll consider that f threshold to be 5. But in the question where like you are doing, for example in the exam or something, f threshold value will be provided to you. If it is not provided, then I think you may use the f tabulated value. But if it is provided, then you will be using the f threshold value. Okay, so we'll then add it. So for the, this is for the first regressor variable. Then what we'll be doing, that when we add the first regressor variable, for example I have added, so for example I have added x2 in the model. Okay, then what our model become, y is equals to function of x2. Okay, so now what will happen, that I'll again test the x1 in the presence of x2. I find out the f statistics for x3 in the presence of x2, and x4 in the presence of x2. Now for them, whatever highest f statistic is, I will compare it with the f threshold, and if it is greater than f threshold, I'll select that. Okay, so for example, so let us consider that take a so here let us consider that at first I have added x2. Then what I'll do, I'll find out the f statistics for x2, sorry, for x1 in the presence of x2, f statistics for x3 in the presence of x2, f statistics for x4 in the presence of x2. I'll calculate the values of this. Okay, now whichever is maximum, okay, whichever is maximum, I'll compare it. So whatever it maximum is, for example, let us consider that this maximum value is fx3 in the presence of x2. Let's just assume. So what happens that I'll compare this value with compare with f threshold. Okay, I'll compare it now. If fx3 given x2 is greater than f threshold, okay, then we add x3 in the model. Okay, we add x3 in the model. Then again, now there come a difference in in this stepwise selection. So we have added x3 in the model. So now what the model becomes, f x2 comma x3. x2 was already in the model, x3 we have added. Here we have checked x3 in the presence of x2, but then further we'll check f x2 in the presence of x3. Okay, then we'll check that this f x2 in the presence that we have already checked. Now we will check x2 in the presence of x3. Now if this is greater than f threshold, okay, if this is greater than f threshold, then we'll take x3 into the model. Otherwise we will reject, eliminate it. Okay, so if this is greater than f threshold, sorry, not x3, we have already added the x3 to the model. But if this f x2 in the presence of x3, so here we are testing for x2, that whether x2 is relevant in the presence of x3 or not. Okay, so if this is greater than f threshold, then we add sorry we then x2 remains in the model. Otherwise we eliminate it. Okay, so here if this is greater than threshold, then x2 will be there in the model, and if it is not greater than f threshold, then we eliminate x2, and then further we'll proceed with y is equals to fx3, and then we'll further eliminate this particular x2 regressor. Okay, so I think this is clear. Okay, I think it is clear. So we'll discuss a question on it, then it will become more clear. Okay.
Okay.
So yeah, so we'll work on the same data as we have considered before. So let me just delete these pages. So yeah. So yeah, we'll consider the same data. And okay, So we'll perform this step by selection. So starting with the null model, which variable enters the model first? So we'll first do the whole analysis, then we'll answer the questions. Okay. So we'll start with the null model. So y is equals to beta naught. Okay, and then we'll try to add x1 to it, x2 to it, and x3 to it, and x4 to it. Okay, so it will be done similarly as we have done for the forward selection. So what we'll find f x1 in the presence of nothing, find x2 in the presence of nothing, okay, f x3 in the presence of nothing, and f x4 in the presence of nothing, and these values are the same as we have done for the forward selection. Okay, so let us write the same values here. So those values were this: 15.33, 5.75. So it is 15.33. This is 5.75. Okay, and I write it from here. 9.86, and this was 2.56. Okay, so here you can see that this is the largest value. Okay, now we will not compare it with the f tabulated value. We'll directly select x1. Okay, so we select x1 since f x1 in the presence of nothing is highest. Fine. So we select x1. So now our model becomes y is equals to beta naught plus beta 1 x1. Now we'll test for x2. Okay. So f x2, x3, x4, whatever you want to add here in the presence of x1. So f x2 in the presence of x1, f x3 in the presence of x1, okay, and f x4 in the presence of x1. Okay, these value also we have calculated in the forward selection process. So that is these values. So this is 6.2857, 6.2857, and x3 in the presence of x1, what we had?
Madam, here f partial f f x1 presence of nil is highest. You are saying that, which also we can verify with the threshold value, no?
No, in the algorithm only, it is in the algorithm it is included that at first we do not have to compare it with the f threshold. Whatever is the f highest, that we will be including in the model.
Okay, madam. Thank you.
Now f x3 in the presence of x1. So what was it? x3 in the presence of x1. This is 3.55 and this is 2. 3.55 and 2. So this one is the highest. Okay. Now we will compare it with the f threshold, and we take f threshold to be f threshold to be equals to 5. This is our assumption. I'm not assuming it by myself. I'm assuming that it is given in the question. Okay, just for the illustration, I'm doing this. So it's 6.2857. So this is greater than 5. Since this is greater than 5, this x2 will be included in the model. Okay, so now since f x2 in the presence of x1 is greater than f threshold, and it is maximum obviously. Okay, so this implies we include x2 in the model. Okay, now we have included x2 in the model, so our model become y is equals to function of x1 comma x2. Now we have seen that x1 sorry x2 in the presence of x1 is significant. Okay, but what about x2 in the x1 in the presence of x2? So here this is a difference. This step we do not do in the forward selection process. Okay, we are doing this in the this step by selection. Okay, so now we check. So this is the difference. So we check f whether f x1 in the presence of x2 is greater than f threshold or not. And if this is not true, then we will drop x1. Okay, so if this is not true, then we'll drop x2 we have added recently, x1 we have added previously. Now we have already checked that x2 in the presence of x1 is significant because this value is greater than f threshold. Now we'll check whether x1 in the presence of x2 is significant or not. So if it is significant, we'll keep it, otherwise we'll just eliminate it. So just uh, so here what is fx1 in the presence of x2. So fx1 in the presence of x2 will be SSRES restricted model. So restricted model consists of x2 minus SSRES x1 x2 divided by MSRES. Okay, so SS residual in the presence of x2 is 240 and in the presence of both is 140. So it is 240 minus 140. Divided by 140 divided by, so the degrees of freedom here n is 25, and since full model consists of 2 regressors, so the value of k is 3. It's 22.
20.
Yeah, so what is this value now?
15.7143.
So it is 15.7143, and which is greater than 5. Okay, so keep uh, we keep x1 in the model. Okay, now we will not eliminate because this is greater than 5. Okay, so now finally f is sorry, y is f of x1 comma x2. Okay, now we'll bring a third regressor into the picture. Okay, so what will find f x3 in the presence of x1 x2.
F4 in the presence of x1, x2.
Yes. So here it will be SS residual. Restricted one is the x1, x2 minus SS residual for the full model, that is x1, x2, x3 divided by MS residual for 1, 2, 3. Okay. So SS residual for 1, 2 here we have already used, so that is 140. So this is 140 minus SS residual 1, 1, 2, 3 all are in the model. So that is 105. 105 divided by 105 divided by degrees of freedom. So here n is 25 and k will be, since we have 3 regressors, so k will be 4. Okay, so it is 25 minus 4, so it is 21. So what will be this value?
7.
So this is
7.
7. Fine. Now we'll calculate fx4 in the presence of x1, x2. Okay. So here it will be SS residual for the x1, x2. So this will be same 140 minus SS residual for x1, x2, x4. So let us see what is x for x1, x2, x4. What is the SS residual? So 1 to 4, it is 120. Okay, so it is 120 divided by 120 divided by 21. So what is it?
3.5.
3.5. Okay, so here you can see that um, so here you can see that this is the maximum x3 in the presence of x1, x2. This is the maximum, and which is uh,
Greater than threshold value.
yeah, so f x3 in the presence of x1, x2. So this is 7, which is greater than f threshold, which is 5. Okay, so this implies we include x3 in the model. So now our model become y is equals to f of x1, x2, x3. But we have seen that x3 in the presence of x1, x2 is fine. But what about x1 in the presence of x2, x3 and x2 in the presence of x1, x3? So in the step by selection, this step is extra, okay, as compared to the forward selection. So for that we check, now again we check for f x2 in the presence of x1, x3 and f x1 in the presence of x2, x3, because we already checked that x3 in the presence of x1 is and x2 is significant, no problem. But what if that x2 in the presence of x1, x3 or x1 in the presence of x2, x3 is not significant? So if it is not significant, then we'll drop that, and if it is significant means it is greater than f threshold, then we'll keep them. So just find these values. So this will be fx2 in the presence of x1, x3. So it is here SSRES for the restricted model. So that is 1, 3 minus for the SS residual for 1, 2, 3 divided by MS residual for 1, 2, 3. And here it is SS residual for 2, 3 minus SS residual for 1, 2, 3 divided by MS residual, the same. Okay, so let me just write it on the next page. So f x2 in the presence of x1, x3. So here this SS residual 1, 3 and 1, 2, 3 we need. So 1, 3 is 155, 1, 2, 3 is 105. So it is 155 minus 105. Divided by 105 divided by, so here the number of regressors are 3. So k will be 4 and n minus k will be 21. Okay. So this is, so what is this value?
0.2952.
0.
2952.
Is it? Let me calculate again. This is 155 minus 105, so it will be 50 multiplied by 21 divided by 105. So it will be 5 10 times and 5 21 times. So it will be 10.
10, madam, 10.
Yeah. And f x1 in the presence of x2, x3. So it will be this will be same. So it will be minus 105 divided by 105 by 21. So here it will be f this x2, x3 in the presence of x2, x3. So x2, x3. So here it is 190. So now what it will be? This value will be
1717.
yes. So it is 17. Okay. So now you can see here that both the values are greater than threshold. Both the values are greater than 5. Okay. So since both are greater than f threshold, we will keep them. We will keep x1 and x2 in the model. Okay. So we have included x3 and we'll keep x1 and x2 also with us. So now our model becomes,
Y is equal to f of x1, x2, x3.
yeah, y is equals to f of x1, x2, x3. Now we'll check for x4. Now we'll check for x4. So we'll check f x4 in the presence of x1, x2, x3. Okay, so it will be SSRES or the restricted, so that is x1, x2, x3 minus SSRES full, so that is x1, x2, x3, x4 divided by MSRES x1, x2, x3, x4. Fine. So it will be f of SS residual in the presence of x1, x2, x3. So this is 105 and for the full it is 100. So it is 105 minus 100 divided by 100 divided by degrees of freedom is n minus k, n is 25 and k is here the number of regresses are 4, so k is 5. So n minus k is 20. So this is
1.
1. Okay, which is less than 5. Okay, now since this is less than 5, we will not include x4 in the model. Okay, okay, so since f x4 given x1, x2, x3, so it is not that significant, is equals to 1, which is less than 5, we do not include x4 in the model. So final model is,
Y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus epsilon.
yeah, so 4 x4 is not included. Okay, so let's answer these questions. After first variable enters, which variable enter next? So similarly here, first the x1 entered, then after x1 x2 enters. Okay, so x2 entered at the second place. After, at the next step, does any variable need to be removed? So do we remove any variable?
No.
No. So no, we have not removed any variable. Fine. Then continue the procedure and give the final model obtained by the stepwise selection. So final model what we have obtained. So y is equal to, as we have already written, this is the final model. Okay, so this is the final model. So I hope all three procedures are clear with you.
Yes, madam.
Okay, so if there is any doubt, then we'll discuss that.
Yes.
Uh,
Question.
yeah.
Use backward difference and forward including step and single step method. In these three methods, we get same solution or different
No, no,
solutions.
yeah, yeah. That also I want to inform you that it is not important. It is not necessary, or I can say it is not necessary that all methods give you same result.
If they are not giving a same result, means which method is the best method, madam?
there is no best method kind of thing. These are three kind of alternatives. So maybe it depends upon the situation. So what situation is better for what kind of circumstances. So if are some circumstances, so there are drawbacks and advantages for all the methods. Okay, so if there is a scenario like if there are many regressor variables are there in the model, so we can do the backward elimination starting from the full model, and there may be a chance that a certain relevant regressor we drop out using the backward elimination, and that may be included in the model if we consider any other method. Okay, so the thing is that these method have their advantages as well as disadvantages. Now, for example, we have a certain situation for which a particular kind of disadvantages is not playing that very big role, so we can use that particular method. Okay, so it is obviously not necessary that all of the method will give you same result, and also we have two selection processes. We have also discussed in the previous class that where we are considering all the regressor all the subsets of the possible all the possible subsets of the regressors we have considered, and on the basis of r square and all those things we have compared them. Okay, now there also we have the comparison factor to be r square, we have comparison factor to be ms residual, r square adjusted, and also the Welch statistics. You cannot say that which method is best in them also. Okay, so you cannot say that which method is best for them, like on the basis of r square maybe you get a different regressor to be more important, and on the basis of adjusted r square maybe you get a different pair of observations which are better. Okay, so it always depends upon the situation, that what kind of situations you are dealing with, and for what kind of situation which method can be more kind of a better compared to the others. Okay, so those things we have not discussed actually, that what kind of method will be good for what kind of situation. Okay, however, there are analysis depending on which we select a particular kind of a method.
It's okay, madam. Thank you.
Okay. So yeah, it is not necessary. Here we have done the example where the it came out to be the same for all the three methods, but it is not necessary. So yeah, I hope this is clear. And also this recording of the today's session I will be uploading on the YouTube. You may access that. Presentations will be like added on the Google Drive. And the last day to submit the assignment is on 20th of August for assignment 5. And the next session we will be like meeting on 31st of August from 6 to 8 p.m. So if there are no further doubts, then we can end the session. And if there are doubts, then you may like tell.
No doubt, madam. Thank you.
Okay. So if there are no doubts, then we'll end the session. Thank you for joining, and let's meet on next Monday, on 31st of August. I'll stop recording first.